Greetings and welcome, Mr. Waddy here with my algebra buddies. We are taking a look at some of the problems from Puzzle Time 5.2, which was all about solving systems by substitution. All right, here's a particularly interesting one. Solving by substitution. Solve one of the equations for one of its variables. I'm going to target this y. The reason I'm doing that, this equation only has one variable in it. It didn't have an x. And any other one I chose would have created fractions, which we don't like. However, I've got a hunch that if I divide both sides by negative 14 here, does this go in evenly? Yeah. So I get y equals, it's going to be positive, and what is that? 4. Y equals 4. And actually, step 1, oddly enough, is kind of like the end of step 2, where we ended up already getting half of our solution. So this problem actually ends up solving itself quicker than normal. So if y equals 4, I can then substitute this into the other equation for y. So negative 4x plus 3 times 4 instead of y is equal to 20. So let's solve for x. I'll finish that O. That's 0 right there. That's good enough. So negative 4x plus 12 equals 20. So after doing that substitution, notice what happened was I now only have one type of variable here, and I can solve those problems great, right, from our older chapters here. So negative 4x equals 8. Divide both sides by negative 4. So yeah, you guys just focus on absorbing the big ideas today. And so I get x equals negative 2. So my solution is negative 2 comma 4. All right. Let's look at another one. I'm going to cruise through this. Cruising. All right. Here's another problem. Step 1, solve one of the equations for one of its variables. I'm going to solve the second equation's y. It's got a positive 1 coefficient. And it also happens to have no x with it. So to solve for y, I would subtract 4 from both sides. I will have y equals 12. Wow, this one breaks down quick. And then I'll plug this in for the other equation's y. Right? Good stuff, good stuff. So I'll have 9x minus 2 times 12 equals 12. 9x, oh, this is step 2, by the way, I'm sorry. Minus 24 equals 12. How do I get this x by itself? Add 24. See, I'm pumped that these problems keep having us rehearse some of even our chapter 1 skills, right? So we get to keep getting better at that. 24 and 12 is 36. How do I get rid of that 9? Yeah, the inverse of multiplication is a division. And so I get x equals 4. So my solution is 4 comma 12. All right? Both of the last two problems happen to solve themselves in less than 3 steps. And that happens whenever one of our equations only had one kind of variable. But that's fine. Let's see, last problem I'm going to do today. Step 1, solve one of the equations for one of its variables. Where is the weak spot? Which variable? All right, so this second equation, and which variable should I solve for? The y, right? I want to get that y by itself. So to move this 2x to the other side, I've got to subtract it. So I'll have the opposite of y equals negative 2x plus 6. So what's positive y equal to? How could I get rid of this minus sign? There's a couple ways you can think about it. You can just opposite both sides completely. You can multiply both sides by negative 1, or you can divide both sides by negative 1. It doesn't matter. But it's just going to change the sign of everything. Negative 1 times negative 2x is positive 2x. Negative 1 times 6 is minus 6. So 2x and negative 2x canceled out, which is why just negative y was left by itself. This negative 1? Oh, 6 minus 2x. I chose to rearrange it. I'm always thinking about like slope-intercept form. So I chose to put this in front of the 6 and wrote it as negative 2x plus 6 rather than, I could have done 6 minus 2x. What I couldn't do is combine those because those aren't like terms because that doesn't have an x, this one did. So here y is equal to 2x minus 6. Oops, that's not my green. There it is. And if these two things are equal, then that means I can plug it in to the other equation for that variable. And the benefit of that, that's the whole substitution part right there. The benefit of that is that I get a single equation with a single type of variable, right? So I'm plugging in 2x minus 6 for that y. Now I've got to use parentheses because I'm going to have to remember to deal with this negative 3 proper. And the way I deal with that negative 3 is distribute. So I will have 7x, negative 3 times 2x, minus 6x. Negative 3 times negative 6 becomes positive 18 equals 17. Some people like subtracting 18 from both sides first off. I'm a fan of combining like terms first. It doesn't matter. As long as you obey the laws of math, we'll all get to the same conclusion. 7x minus 6x is 1x. And remember, since these are on the same side of the equation, I don't have to like add 6x to both of them. No, they're already on the same side of the equal sign, so I just combine them. All right, whereas over here, I wanted this on the other side, and the way I do that is by, right, subtracting in that case. To get x by itself, I'm going to subtract 18. And I get x equals negative 1. It's only half my answer. How do I find the y? How do I find the y? I can plug this in. I can plug it in here. I can plug it in here. The best place is to plug it into the end of step 1. If you do that every time, that's already solved for the other variable that I'm looking for. So step 3 is y equals 2 times negative 1 plus 6, right? I've replaced x with negative 1. And so that is equal to negative 2 plus 6. I get y equals... Oh, thank you. Good call, good call. Helping me out. That was a minus 6. Yep. So that's negative 2 minus 6 equals negative 8. So my solution is negative 1 comma negative 8. All right, so that is substitution. Thanks for watching, friends. Bye-bye.